All right, so the lesson 5 practice, the data set represents the number of errors on a typing test. And notice it's already in order 5, 6, 8, 9, 9, 9, 10, 10. I would actually move these next values kind of up just because it'll be easier to look at here. We need to count the number of numbers. 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So there are 2 middle numbers. Okay, there are 10 numbers total, 2 middle numbers, the 5th and the 6th numbers. Which would those be?
Uh, 9 and 9.
9 and 9. So when they're the same, the average is pretty straightforward. It is 9. Now, unfortunately, and this is one of the mistakes I've made in the past, is once you get that is the median, you actually don't want to circle it again. You want to break the data set in half right there. And you have to use the left half and the right half for the Q1 and Q3. Okay, so we will interpret the value in this situation. 9 is the most likely number of errors of average error, not average. Let's say it this way. We want to say something about it being the middle. So let me do it that way. Oops. Okay, let me cross this out. It's the middle number of errors. Something like that. Your teacher may have specific words. You're welcome to use whatever they recommend. Is that okay? It's supposed to measure the center of the data. Maybe that's probably the better word to say, your center of the data set.
Yeah.
Okay, to find the IQR, you do need Q1 and Q3. Q1 comes from the left half. It's the middle number in the left half. If it has 2 middle numbers, then you have to take the average. But because there are 5 numbers, it is just that middle number.
Yeah, 8.
8. Excuse me. And for Q3,
10.
10. So the IQR is 10 minus 8, which equals 2. Is that okay? Clear?
Yeah.
All right. So no box plot for that one. Are you guys using your calculator much in class?
Yeah.
So we could also do that. I think we did some of that last time as well.
Yeah.
Okay. For the next one here, they're no longer asking about the median. They're just asking about the mean or the average. So it's a matter of just adding up all the numbers, dividing by the number of numbers. You can also use your calculator and put it in a list. Do any of those sound better than either of those? Oh, he's gone. Hey, Maris, are you back? Just ask you to unmute.
Yeah.
All right. So did you add up the numbers yet? Do you have a total or an average when you divide by the number of numbers? What is the mean that you have?
One sec. Uh, 16.
Very good. Okay, you got to get that right to do the next part. So you sometimes will do the calculation twice, to make sure. From class, you might remember that MAD doesn't actually mean mad. It means mean absolute deviation.
Yeah.
Okay. So in class, you probably saw formula. The formula is the difference. So it's the difference. It's like 13 minus 16 for the first data term. And then the absolute value of that number. And then you do the same thing for 14 minus 16.
So -3 and -2.
Then you got to keep going for all of them. So there's a bunch to do here, 10 total, right? So the first one is 3, 2, and 2. The absolute value means it's always positive.
Oh yeah.
And then you keep going. Now the ones for 16, the nice thing about those is the mean absolute deviation is 0. So you don't include those. 18 minus 16, 18 minus 16.
Uh, 2.
And then and then 19 minus 16.
3.
So from here, you add all the numbers up. If you add them all up, let's see, that's 7, another 7 is 14, and then you divide by the number of numbers, which is 10. Remember, I didn't do the zeros for the 16, and that is your MAD.
Oh. All right.
Any questions on that?
No.
So I'm not sure how you're going to remember that. It's also interesting that you guys are doing this because it's usually a more this topic's usually taught in more advanced statistical classes. But I mean, it's not that difficult. I mean, it's just taking the difference and adding them up. But it's usually given to students taking some sort of business analytics or things like that.
Oh.
All right. So here we go. Looking at number three. Number three. So this is a dot plot. Describe the shape of the distribution shown in the dot plot. The dot plot displays the golf scores from a golf tournament. Have you ever played golf before?
Kind of.
Kind of. Okay. So the what the dot plot tells you is that, for example, there were 2 players at 133 each, 3 players at 134, and so on. Okay. And when it's the shape of the distribution, you'll appreciate this. You have to make a drawing, a curve as best you can that sort of models the data set. How did I do? Good, bad, medium? What do you think?
Decent.
Yeah, it's just okay. But it's what you're trying to get is an idea of whether more falls to the right or to the left.
I think the term is skewed to the left.
So this one is skewed right. It's got a
Which?
tail to the right. Like you've got a
Oh
dog,
yeah.
but cats are kind of the better. If you can think of a cat, its tail. I don't know if you like cats, but okay. If it were to go the other direction here, this is skewed left. That's the other one you might see. And then a couple other distributions you might need to know. The kind of the one that most students know is the normal or the bell curve.
Oh.
And then sometimes you see things like this. It's called bimodal. It's got bi meaning two like humps.
Oh yeah.
This. And then the other one you might see is a uniform distribution. It's the same everywhere. This is probably all extra, but nevertheless, you now have a little more information. Okay.
Yes, that's good.
Now symmetries, let's just look at symmetries real quick for some of these that I just wrote. This one, for example, is symmetry. This one has symmetry. This one has symmetry. The skewed ones do not have symmetry. You can probably visually see that pretty well. Like there's not a dividing line that makes it look the same on the left and the right.
Yeah.
So that is relevant here for number 4. If you had this printed in front of you, it would be really good for you to try to sketch the same thing I did, which is like a little distribution curve here. But probably good enough.
Yeah.
So what do you see here? Is it bell shaped?
No, it's bimodal and symmetric.
Yeah. Great. Okay.
All right.
Okay. From here, okay, another problem here. Sorry, I didn't know how far this was going. 5 is another dot plot. Um, let's do this. Okay, so what we want to do here, actually, I shouldn't snip all this in. There's too much stuff going on here. We want to look at the graph and collect the data values and maybe make them, maybe put them in a list if that's what you're comfortable with. You got to have the data though, because we're going to calculate the mean and median of them. So it's good to have it in a list. It's good if the list is in order. And then one of the things I like to do, I always try to count at the end to make sure I've got all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I've missed one. Oh boy. Up there it is, 113. Thank goodness it wasn't too far away. So will you find the mean and median of this if you're not already doing that? And you probably want to use list 1 in your calculator for this one.
I got for the mean 108.6.
Right. How about for
And
the, does the median also show in your one variable stats?
yeah, I got 118.
Okay. The median for sure is correct. It's these two middle numbers. The mean, give me a moment here. I just want to check because I'm using something else and just taking a while to enter the data. 118, 119, 119. So the most common mistake is to enter the data incorrectly, which is what I've done now twice, 112, 113, 3 116s. That's where my mistake is. What went on? All right. All right, so summary stats. Sorry, just to get this right here. I got a different number for the mean. Of course, 112, 113, 116, 116, 118, 118. Okay, yeah. Could you double check that you've entered this correctly? And sometimes it's better to check like bottom to top versus top to bottom.
Okay, I see. Now I got 118.3.
That's much better. Yeah. Okay. I got 0.25, but 0.3 is also good. Very good for that. So you'll notice that it actually asks you to find those values. It says, what is the mean, and then interpret. What is the median? Interpret. And so I think the thing that I should have said earlier that is related to the mean and median is that these are both considered measures of central. Have you heard that before?
Yeah,
So it's like, where is the center of the data? So we're giving those two values, 118.25, 118. They're essentially the same. The reason they're the same is if you look at the data set from a symmetrical point of view, it's kind of balanced right there in the middle at that
yeah,
118. It's roughly not perfect, but it's close enough. Um,
yeah.
so I guess some words to that effect. You might want to include the context, wages earned, it's the measure of central of wages earned might be a good thing.
All right.
Okay, next question here has to do with box plots. It says, and why don't I grab that box plot? I'm going to grab a box plot that's on there to help answer it. So the box plot contains the median, Q1, Q3, the max, and the min, but there is no average, and there's no way to find the average. The reason is you don't know how many data points are contained within each box. You just know that
Yeah,
25% of the data is in each,
yeah.
so I think that's kind of sufficient there to say that you can only find the median, but not the mean.
Yeah,
And then for 6, this is kind of what I had in mind when you said box and whisker plots today. I was going to suggest that we kind of go backwards, like here's the box and whisker plot, and let's answer some questions from it. All right, so what is the median value here?
— 118.
Yes, very good. Maybe say degrees Fahrenheit. There are units of measure needed. I don't know if that's where your instructor was going with the whole, like, wanting you to give some context to your mean and median, but that's important to do.
Yeah.
Okay, so you mentioned some standard deviation stuff earlier.
Yeah.
Let's find the standard deviation here. Standard deviation. There are two formulas. Do you know if your formula, did you get a formula in the class? I should start there.
Um. No, not that I remember.
Okay. So there are two formulas. One has an n on the bottom and the other has an n minus one. And I have no idea which to tell you. Let's just say, let's go with just n for now. So I'm going to give you 4 data values. 3, 4, 10, and let's go. Let's make it 9. Okay, so let's just say I give you 4 data values. To find the standard deviation, step 1 requires you to, and I'm going to show you by hand before we go to the calculator, it finds the average. So will you quickly find the average of these 4 values, please? Nope, I've messed this up. I apologize. Darn it, I am so bad today. All right. Sorry, 19.
All right.
I just woke up on the wrong side of the bed, as they say.
Eight.
You added up these numbers and divided by 4.
Yeah.
Uh, the sum is 36 divided by 4.
Yeah.
That is 9.
Wait. Hold on. I don't know how I got that. Wait.
It's okay. It's okay. Sometimes we're just off. So
You just gotta.
yeah. So the next thing here is to make a table, and the table in the first column contains the data points 3, 4, 10, and 19. Okay, so the next column, you take the sample and subtract the mean. So you take 3 and subtract 9, that's -6. 4 and subtract 9, -5. 10 subtract 9, which is 1. 19 subtract 9, which is 10. Next thing is to square the number you just found. So you have to square square these numbers here. So it's -6 squared in parentheses, that's 36. -5 squared in parentheses, that's 25.
25.
And then keep going here. Make sure these numbers are always positive after you square them. And then 10 squared,
Is
100.
100.
Okay. The step 2 is to make this table. Okay. Not that difficult, just, gotta know how to do it. Then you have to find the sum. So you have to add them all up.
Yeah.
So go ahead and give me that total, please.
162.
162. Okay, now we're ready for the formula. So the standard deviation is that is the square root of that number you just found divided by the number of numbers, which in this case is 4. So it's the number of numbers. So can you calculate that for us, please?
Uh, 40.5.
Yeah, you got to take the square root of that.
Okay. Wait, can it be a decimal? It's already a decimal, 40 point, or does it have to? What's it called? I don't know. Like, is it with the? I'll figure it out. Yeah, 6.4. Is that? Are you? If you're saying something, I can't hear it.
I apologize. I accidentally hit the mute button on accident. Do you see there's an SX and a sigma X?
Yeah.
So we calculated the sigma. Sigma is a Greek letter, a little O with a little like thing on the end. That's the one you just calculated. The other one's also reasonable, but I don't know. Like, I don't know which one your instructor will want. So this is one of those things that you might ask your instructor Maybe say, hey, I was doing a problem and I got, I noticed there's this SX and sigma X and they're really close. Like, which one should I use? And then you'll have your answer for that.
All right. Yeah, I'll ask them.
And I apologize for that mute thing. It's an ongoing problem. All right, so what does standard deviation mean? Standard deviation, sigma, it tells you the spread of the data.
Okay.
So it tells you like how far from the center your data is.
Oh,
Okay, so without calculating it, let's look at two data sets, 9, 10, and 11, 1, 10, and 19. Which has the greater spread of data? Which one is more spread out?
the first one.
9, 10, 11. See how those are really close to 10? 9 and 11 are really close to 10. 1, 10, and 19 are very
Oh
far
wait.
from 10. Remember when we had to do the whole social
Okay.
distancing thing? Kind of like
Yeah.
that. It's like, okay, this is pre-COVID, this is post-COVID, right?
Right.
Sometimes you still see the 6-foot stickers on the ground in various places.
Yeah.
Wait a second. I'm so sorry. I'm not sharing my screen. I apologize. What a terrible thing here. All right,
Just
now
having one of those days.
it is just not. So I was trying to show you 9, 10, 11, 1, 10, 19, which is spread further apart. So it's the ones that are further from the center. These both have the same center, but
Yeah.
1 and 19 are much further than 9 and 11. All right, well, we're going to go ahead and stop there. Thank you for enduring with me, and I hope you got something out of it today. I'm sure you did.